Hello, I'm Doug Atkinson here at Solutions Review, and I want to thank all of our keynote speakers, expert moderators, panelists, and solutions sponsors for participating in this year's Insight Jam Live. This has been a big year with the launch of the InsightJam.com community site and the amazing growth of the Insight Jam YouTube channel, which now has over 500,000 subscribers. Much of this success is tied directly to the video events, podcasts, and panel discussions we have been producing, and none of that would be possible without the thoughtful participation of the many IT professionals who are generously sharing their expert insights for this latest jam. We are building Insight Jam to be a place to celebrate enterprise technology with best practices, expert analysis, and solution showcases. And we want all of you to join us there to keep the jam going into the new year and beyond. If you haven't joined Insight Jam, please do. And if you already have, take a moment to invite some of your colleagues. And again, thank you all for being here and enjoy this event.
Solutions Review presents the Insight Jam Expert Keynote.
Hello, good day. I'm Mike Magalsky with InfoVia, and I'm here to present data security in Overdrive in collaboration with Insight Jam and InfoSecure, where we are going to teach you to share your data widely while protecting it fiercely. I work for InfoVia. I'm the chief architect here. Our mission is to bring peace of mind to growing organizations through simplified and secure data management. We offer data strategy, planning, implementation, data warehouse automation, and mentorship to your team to help your team produce rapid productivity. We also offer perspective because the elegant solution is seldom obvious. Our InfoSecure solution is innovative and gives data access and security to your data so that you can share it widely and protect it fiercely. And we do have a patent pending on that solution. Some of the clients we've worked with in the past, broad spectrum of industry, from everything from education to agriculture, manufacturing to insurance. And the solution that we're presenting today came up out of a dilemma. And this was a lawsuit that was filed across the pond, across international borders, where Micron technology was infringed upon by a Taiwan company and a Chinese state-owned enterprise. And they were found guilty of breaching Micron's data privacy in a corporate sabotage scenario, where an individual inside the company walked away with data secrets and sold them to these other entities. Now, that person went to jail, but the cat was out of the bag, and we had to come up with a solution that allowed us to share our data widely, internally, but also externally, while still protecting it from data threats. The need for speed is probably obvious, but as AI and machine learning become more prominent in the industry, more and more needs to share data are being produced, being promoted, being presented to decision makers within organizations. And Gartner says that they had a report recently that said that the more we share data externally, the more profitable the company is. In fact, they went so far as to say that companies that share their data externally are 3 times more profitable than those that share them internally only. So that need to share your data widely while protecting it from theft, breach, or even accidental and inappropriate sharing is the objective today. We believe that you can achieve that ease of sharing of your data while still managing your risk and your team being more productive at the same time. So we started with a set of requirements. First of all, the solution needs to be simple. We can't bring in a bunch of new technology and intercepts. It has to be able to run on your current technology. It has to be scalable from any number of rows in your data sets, from 10 to 10 to the 10th power. So there were examples of billions of rows of data that were secured with this approach. Had to be performant so that queries would run in the neighborhood in the same order of magnitude of speed with security on top of them as they did without. And we'll actually tell you in a little bit how sometimes we even improve the performance of queries by adding this approach on top. They had to be portable, had to run on cloud and on-prem databases, several different major DMS platforms, all with the same approach, so that companies, organizations could secure their data, whether it be in the data warehouse or their source system platforms or on a new cloud lakehouse or something to that effect. And then finally, it had to be applicable to the key modeling paradigms for data analytics. And finally, of course, with the advent of LLMs and AI solution machine learning within the enterprise, we want it to be able to be enforced there as well. In addition to the initial use case, we saw more and more breaches come about, costing millions, if not tens of millions of dollars to companies like hospitals, education organizations. Here's an example of where California life sciences company or university faced a massive breach, costing them lost time, effort, and privacy to their students. So let's talk about what options exist to create a better data sharing environment. Oftentimes companies first go towards the micromanaging of their data, so only allowing the minimum number of users access to maybe whole databases or whole data platforms, and very few get access to the micro level data. Obviously, we don't like that approach because it has high overhead and it restricts who can see which data in a way that is more about saying no first instead of saying yes and being able to share freely to those who would be appropriate. Oftentimes they try to handle this in the reporting environment, where they would create multiple versions of reports to say that that filter or mask the data differently for an individual contributor than they would for a mid-manager, than they would for a director or executive. That requires report sprawl or some number of copies of reports that essentially report the same data, but simply just changing the filtering and masking within those reports. Another option is to manually extract and circulate the data for obvious reasons. That's not a good choice, although it is probably used in more cases than we care to admit. And manual errors occur in that process. Usually, when you add the human element, this is how breaches occur, by sending the right data set to the wrong person or vice versa. And finally, leveraging inadequate technologies. We believe that the technology that you already have is appropriate for managing your security. So we're going to teach you how. At the base of this approach is the idea that you should bake security into your data platform. You should design it with security in mind, just like you wouldn't add security at the end of the process, like you wouldn't add flour or sugar at the end of your cake building process. It ends up with something like this that isn't anything near what you intended. Not only does it not look good, it doesn't taste good either. And so creating a data platform with security baked in to the approach is the premise at the foundation of what we're teaching today. Another premise at the foundation is a hat tip to my friend Wayne Eckerson over at the Eckerson Group. He's also one of the experts on Insight Jam, and his team talks a lot about data as a product, building and standardizing your data delivery as products. So one of the things that stuck out to me in the Eckerson's presentations were this idea that a data product has multiple components. Specifically, you're encapsulating your transformation logic within that data product. You have metadata around it that describes it and allows it to be cataloged. You have a schema to make it easy and consistent for consumption. It defines the relationships between the objects. And finally, there are views representing logically representing the physical data. and offering distinct slices for consumption. That distinct slices for consumption is where the security comes in that we will be presenting today. So once you've engineered your data with the first 3 bullets there in the components, you finally create a view of that data that can, I'll say, polymorphically create slices of that data for consumption. I say polymorphic because like in object-oriented programming, a polymorphic data object is multiple things to multiple people. So depending on the hat you're wearing, the context of who's asking for the data is matters and is determined through the security layer so that the data that's offered to the consumer is appropriate for that person. I'll show you an example of that in a moment. The benefits of data as a product, according to Eckerson, increased productivity, automatically incorporating your changes. So as the life cycle of your product, that is your data, increases, you're incorporating those into the product that's being offered and therefore to the picture that the business is consuming. And finally, you have monitoring capabilities and access control for security. So we'll show you how that happens in a data as a product. So here's an example of what a data product that is secured through this approach would look like. Let's say you have a set of claims paid to a payer on behalf of a provider involving a patient, okay? And this is clearly sensitive data, falls under the PHI guidelines in the HIPAA agreement. And what you have here is a couple different groups of data. So you have the Kaiser payer and the United Healthcare payer, 2 different payers submitting claims. Probably you don't want one to see the other. In fact, you're probably contractually obligated to keep them separate. Likewise, because of HIPAA, you're probably held accountable for people within one family or within one insurance structure, the member and his or her family, to be secured accordingly. So one person consuming this data, let's say that this is a Kaiser administrator, somebody in the payee network that needs to process these claims, should only see Kaiser's list of rows as opposed to the United ones. Likewise, if someone is consuming this data and shouldn't have access to the patient identity, then that patient identity could be masked or partially masked appropriately. So that's where we come up with cell level security, is by adding row filtering and column masking on top of each other. You end up with the ability to manage access to individual cells. I could even say that a specific user can only see amounts for provider Walgreens under the payer Kaiser, and otherwise they can't see amounts. So that amount, $28 there, would only be visible and not the amounts surrounding it. So that's kind of a concrete example for what secure data would look like when consumed by the user. So let's talk a little bit more about how we would build that, how we would build a data product that is secure in that way. We would start with the creation of what we call InfoSecure metapolicies. So these are policies that are defined inside of relational metadata. Relational in that they're stored in a relational database. Metadata in that they define a mapping between the data assets, the rows, the row identifiers or column identifiers, and the roles, ROLES, the row identifiers and the roles that would be consuming those. So the roles would be which hats someone wears within an organization, like in role-based access control, okay? Now we take those metapolicies and we replicate or ingest them into the various data environments that will be consuming them. The reason we do this is that a database optimizer is very good at set theory. It's very good at determining the intersection of two different data sets. It's called a join. It's defined. It's what they do best. And the optimizer, as long as it has knowledge of these policies, can apply the security at runtime, at query time, in an extremely efficient manner. In fact, we've mathematically shown that it's the most efficient manner in which to apply policies. So that's why these policies, once defined, are pushed or pulled into the data structure itself, so that the database optimizer can be aware of what's being shared. Next, the InfoSecure user interface asks the configuration admin to map the policies to the columns and rows that they represent within the database, and then it generates a set of secure views within the database that are then to be consumed downstream by all the uses of the data over at the right. And we've listed several of the common uses. You have BI reports and analytics that could be created through any number of BI tools. You have applications that consume that data. It could be through an API, or it could be through direct data access. It could be AI machine learning models, or even ad hoc SQL if you have analysts that are running ad hoc SQL themselves. And what this does is it creates a logical barrier or filter or curtain, you might say, between the actual data and the user that's using it, such that when the data is pulled through those secure views, the filtered and masked results are produced to the end user. The last piece of this puzzle is the identity of the user. So the identity needs to be known and passed through from the various consuming applications on the right side into the database. Now, this is a common practice, but it's not always followed. In order for the database to appropriately manage access control, then it needs to have the identity. It needs to be able to trust that the identity of the person connecting is who is actually consuming the data on the other end. One more thing to note here is that under the AI and machine learning models, RAG agents can be used in this respect to compartmentalize or to create this secure data sharing environment to feed your machine learning models, including large language models. So just another one of the ways that this can be applied is through a RAG agent in the large language model, or I guess any size. Small language models works the same way. The benefits of this approach is that your access to the data is intuitive and reusable. Why do we claim that? Well, because they're accessing data objects in a database, just like these tools are already used to consuming. So your users, your BI developers, your AI machine learning data scientists, your application developers, they don't need to learn a new way to access data. They just consume it through the views that already exist and are made available to them. All the other raw data in the database sits behind access controls at the database level so that users can't access it at that level. And all the views that are created make for ways that the average user can access with an intuitive SQL interface. APIs, I guess, would be another way that would be intuitive there. The metapolicy-based governance approach means that you can create your policies outside of your data definitions and put the interface for doing so in the hands of your business users, as opposed to your DBAs or other administrators within, say, the IT or the data department. This puts the management of those policies in the hands of those most closest to the knowledge of who should consume that data. So you might create a rule that says PII is available only to the individual themselves or to a manager with PII access. In that case, you have the business managing those policies, and IT is simply administering the framework that enforces them. It's configurable. It's a low-code approach. The code that is used is generated by the InfoSecure API, and it's deployed into the environment as views, which makes it, again, back to the first point, intuitive and reusable. It's technology agnostic, meaning regardless of which relational database platform you choose, as long as views and joins are supported, the engine knows how to enforce the meta policies on the client data or the raw data to produce the filtered and masked results. It also means the technology agnosticism also gives you the ability to migrate quickly. If your CIO decides that you are going to become, change database platforms, become a different technology shop, maybe go to open source versus some other vendor, then that can quickly be, the policies and the views can quickly be transitioned and generated on the target platform. And we've seen several examples here where, in using this approach, where when the customer moved to a new technology platform, the meta policies were simply transitioned to that platform and the views were regenerated, and it just worked in the process. Helps insulate you from technology lock-in or vendor lock-in in your data platform as well. And finally, your database layer cell level enforcement means that you have that cell level granularity if you need it. You have row filtering, column masking overlaid on each other, and it's done at the database layer, which is architecturally the right place in your architecture to enforce security, because it's where every application, every consuming client has in common the database. So when you enforce it at the database, you get consistency through that support. It's been implemented in a myriad of industries, as was noted in the logo slide earlier on. We've listed some of those here, but all that to say that the policies can be created to implement healthcare policies like PHI and PII relevant policies, as well as FERPA policies in the higher education space. Global manufacturing, trade secrets, down to financial industries. So regardless of what types of policies you're implementing, the flexibility of the access control policies and the maintenance thereof allows this to be fanned out to multiple industries. So in the end, your business gets the benefit, or they win, because there's easy access for all their users, whether they're coming through an existing application or whether they're issuing SQL commands themselves. This provides an easy access point. There's consistent policy enforcement. It lowers risk. It's highly valuable to auditors. If you can run a report against structured data that defines your policies and the mappings of those policies to your users through roles, then it's easy to explain to your auditors who has access to which data. And finally, it's future-proof, because once you configure these policies, they can be fanned out to various industries, but maybe more importantly, to different technologies within your data, within your enterprise data platform, whether that be in the data migration discipline, as I mentioned earlier, if you're migrating from one technology to the other, but also on your source systems. If you're doing reporting against your source systems directly, then you can set up these meta policies in your source systems and apply them in that regard, or in that method as well. Technical benefits, we've kind of talked about these before, but the scalable in that as this layer of security is applied in the database, to the extent your database is scalable, and on the cloud that is often an infinite scalability offering, your enforcement of the policies is scalable to the same extent. It uses the optimizer, so it's optimized, and we have mathematical formulas and case studies showing that an execution of a policy against the data in the database is mathematically the most efficient way to manage access control. Database platform agnostic. We've talked about any relational database that supports views and joins. And finally, your ease of implementation, because since it generates the code and that code creates database objects that any tools are accustomed to consuming, then it's easy to implement and it's easy to enforce. It's also easier to maintain. And finally, again, my name is Mike Magalsky. I'm with InfoVia, the inventors of InfoSecure, and we believe that we can help you share your data widely while protecting it fiercely through the use of the principles described in this presentation today. Feel free to reach out to me. I'm at infovia.com or at infosecure.com. My email address is there, and I'd be happy to connect with you on LinkedIn. Happy to do a demo, show how it works, even in your environment, with a little proof of concept. And we'd love to have that conversation with you. That's all for today. Thank you so much.
For video highlights, replays, and more, visit InsightJam.com.